Hi, this is Gigi from Kauai Community College. In this video, we are going to talk about the derivative. And we are going to use the definition of the derivative. So if you were in my class, you have seen this derivative as the instantaneous rate of change. That's right. The instantaneous rate of change is being defined as the derivative. And now we're going to talk about that as a derivative function. Okay, so you have seen this. So you have seen the definition of instantaneous rate of change as the limit as h go to 0 of f of x plus h minus f of x all divided by h. That is now being defined as the derivative function at any given moment x. Okay, so that is f prime of x, meaning the derivative of x. That's the definition. Okay, so that is the derivative function. So same as before, the derivative function is that instantaneous rate of change that you have found before. Okay, so for this problem, we would say given the function f of x is equal to x squared plus 2x, find the derivative function. Well, there's the definition. So we would say the derivative function is limit as h goes to 0 of f of x plus h. Wherever I see x, I will plug in x plus h. So there would be x plus h squared plus 2 multiplied by x plus h. That minus f of x, which is x squared plus 2x, all divided by h. Okay, so now all we have to do is to go ahead and clean that up. So that is equal to limit as h goes to 0 of x squared plus 2xh plus h squared. That's the perfect square. Then distribute the 2 plus 2x plus 2h. Distribute the negative sign in the front because we're subtracting everything there. Minus x squared minus 2x all over h. And so we will see that x squared minus x squared is 0. 2x minus 2x is 0. Everything else that is there has an h in it. So we can divide everything by h. And so when we divide everything by h, we would say the derivative function is, or f prime of x is, limit as h goes to 0 of 2x plus h plus 2. Okay, because we divided everything by h. So when h is approaching 0, this is going to be approaching 2x plus 2. And this right here is our derivative function. And we call that f prime of x, meaning the derivative at any given moment x. Or we would say from earlier lesson, we call that the instantaneous rate of change or the slope of the tangent line. So what is the derivative? The slope of the tangent line at any given moment. Okay, so then to proceed to find the derivative when x is -1. That is a prime of -1 is going to be 2 multiplied by -1 plus 2, and that is 0. Okay, next question is asking, when does the function has a horizontal tangent line? Well, as you can just saw from part B, that represents slope of tangent line at x is equal to -1. So we can see when x is -1, the slope of the tangent line is 0. So it must be a horizontal tangent line. Okay, but are there any other points where the slope is 0? Well, if we had to go think about it, we would go ahead and say, well, the slope is 2x plus 2, and we want to know when it has horizontal tangent line. So set the slope equal to 0, and when we solve, the only point that we'll get is -1, which is what we have done in part B. So when does f of x have a horizontal tangent line? When x is -1. Or if we want to really say a point on the graph, we would say, what is f of -1? That would be -1 squared plus 2 times -1, and that would be -1. So horizontal tangent line happen at the point -1, -1. Or we can just say at x equals -1, whichever answer you prefer to see it at. Okay, but again, for the lesson, we would say the derivative function is the instantaneous rate of change, or the slope of the tangent line, and that is the definition.